Hey everybody, so today we'll be solving the February-March 2023 exam paper, the code for which is 0620/22, essentially the IGCSE MCQ paper, and it is very important for IGCSE students as well as the O-level students to go over this paper because you need to understand that the recent papers give you an idea of how Cambridge is most likely going to test you guys in the upcoming May-June examination. So it's not just, practicing your own components, practicing your own variants. You should also look into other components and other variants, and even O levels should look into IGCSE and IGCSE should look into O levels. Then 95% of the syllabus is the same, only certain concepts are a little certain additions are there in IGCSE and certain additions are there in O levels and certain subtractions, but you need to understand that it will give you more command over chemistry in general and help you understand the concepts better and answer the questions better, right? So it's better for both O levels and IGCSE students to go over this paper. And I've already written my name. The reason why my name is already written is because obviously we had a class yesterday, a live class yesterday, in which we managed to solve 15 MCQs of this particular paper in around 55 minutes, because obviously I was discussing and revising all the concepts related to each MCQs and all the potential MCQs that could be created or that could be asked related to the specific MCQ, related to that specific topic. So we dissected each and every MCQ. We went into in-depth explanation for why all the options were wrong and a particular option was right. So we discussed all the reasonings, right? But in this particular paper, I just want to, in this recorded lecture, I just want to solve the paper, breeze through it, and explain the things that are only related to the MCQs, not go into in-depth revision of the entire concepts and so on and so forth. Just want to solve this paper for you guys. Okay? So without further ado, let's start off with the questions. It says substance M is a solid at 30 degrees Celsius. So between 20 and 40, there's like 30 degrees Celsius right here. It's a solid at this particular temperature. And it's saying the substance is heated to 80 degrees Celsius. So it's heated up until this point. And it's saying the temperature is measured and it cools down to room temperature. The cooling curve is shown. So obviously the cooling curve shows you how the temperature of a substance changes as it's cooled down. So the temperature is decreasing, becomes constant at 40, decreases from R to S, and then becomes constant at from S to T, right? So it's saying between which times is substance M freezing? Obviously, freezing is the process of converting a liquid into a solid by cooling it down, and the freezing point would be determined by it's basically the constant temperature at which a liquid would change its state into a solid, right? So whenever there's a change of state, the temperature must be constant. So P to Q is not going to be the answer because the temperature is decreasing here, and R to S is not going to be the answer because temperature is decreasing here. So A and C are automatically wrong. Between Q to R and R to S, which one would be right? The answer can be evidently seen by this particular point right here. If it has said that at 30 degrees Celsius it's solid, that means that before 30 degrees Celsius it had been converted into a solid. So between Q to R, the liquid state is actually converting into a solid, and that is why from R to S the solid is further cooling down, right? And S to T is just there to confuse you guys. It's showing nothing. It's basically telling you guys, the Cambridge examiner is telling you, okay, after a solid is made, there's again a change in state. We know that after a solid there is no change in state. The solid can only further cool down, just like that. Beauty there, right? So Q to R is the right option. B is true. Now it says which gas has the fastest rate of diffusion? I need to take my calculator out for this. I put it back in my bag. Okay, so diffusion obviously depends upon two things. It depends on the temperature and the mass. The molecular mass, the atomic mass in argon's case, the lower the molecular mass or the lower the atomic mass, the faster the rate of diffusion, because the lighter the gas, the faster it can travel, right? The speed would be greater. So between A and B and C and D, we have to just calculate their masses. So argon is basically 40. You can check the periodic table out. Carbon is 12. You have 2 of those, times it by 2. Plus hydrogen is 1. You have 6 of those, times it by 6. You would get 24 plus 6. That's 30. Here hydrogen is 1. Chlorine is 35.5. Add them both together. The molecular mass is 36.5. Hydrogen is 1. Times it by 2 because 2 are present. Sulfur is 32. Obviously 32 plus 2, that's 34. So the rate of diffusion, the fastest rate of diffusion will be of the one which has the lowest mass, and obviously it is C2H6, which is your ethane molecule, right? So B is the right option here. Now, here it's saying that question number 3 says there are two stable isotopes of bromine. The mass number of bromine isotope, isotope 1 is 79. So Br is 79. And obviously, the proton number of Br is 35. And the second isotope is basically 81. And this is 35, obviously. And isotopes are different atoms of the same element having the same number of proton, or you could say having the same atomic number, because proton number and atomic number, they're both the same things. They both tell you the total number of protons, but different, and isotopes have different neutron number, or you could say different nucleon number, or you could say different mass number, right? This is the mass number, also known as the nucleon number. This is the mass number, also known as the nucleon number, and the number of neutrons can be determined by subtracting the number of protons from the nucleon number, right? So 79 minus 35 and 81 minus 35, right? So saying which statement is correct. A says the isotopes have the same number of neutrons. No, the isotopes have different number of neutrons, not the same number of neutrons, different. It's evident here. 79 minus 35, 81 minus 35. So A is wrong. B says the isotopes have different chemical properties. No, the isotopes have same chemical properties, and the reason why they have the same chemical properties, because chemical properties depend on the number of valence electrons, number of outermost electrons, because the outermost electrons are involved in chemical bonding. They are involved in either losing electrons, gaining electrons, or sharing electrons. So that is why the chemical properties are the same, but the physical properties might be different because of, it has a different mass, this has a different mass number. So obviously one might travel faster, one might travel slower, and so on and so forth. So physical properties might vary because the nucleon number is different, the mass number is different, but chemical properties remain the same because that depends on the number of electrons, which are the same number of outermost electrons, right? So B is wrong. C says they have different number of protons. No, they have same number of protons. C is also wrong. D says the isotope, I don't even have to check D, I can just circle it, but if you check D, it says the isotopes have the same number of outermost electrons. Yes, and that is why they have the same chemical properties, not different. So question 4 says which statement about the ions and ionic bonds is, I'm also still explaining it to, to a larger extent. I'm still explaining each and every MCQ to a larger extent. Otherwise, this entire paper can be completed within 19-20 minutes, to be very honest, right? If your concepts are clear, you could do that. But that doesn't mean start racing with yourself and be under pressure when you are attempting the paper. Go slowly and steadily and slowly, complete the paper. You will have more than enough time if you breeze through it, right? Take your time, but don't get stuck on an MCQ. Just try and breeze through the paper. If you think that an MCQ requires thinking, requires you to perform certain calculations, skip that, do the other MCQs, come back to the same MCQ again, okay? But I'll obviously just be going in the chronological order. Okay, so which statement about ions and ionic bonds is correct? Bromine atoms form negatively charged bromide ions. Yes, they do, because bromine is in group 7. It needs one electron to become stable. Therefore, it's gonna gain an electron, and bromine is gonna gain, when it gains an electron, the bromide ion is formed, which is negatively charged. So that's true. A is the right option. But let's check B and C and D out. B says ionic bonds form between elements of group 7. They don't form between elements of group 7. Between elements of group 7, there's another type of bonding that forms, which is called covalent bonding, because group 7 elements are all non-metals, and the bonding that takes place between non-metals is basically the sharing of electrons, which is covalent bonding, right? So ionic bonds don't form between elements. They form if you have metals and non-metals. So there's going to be a transfer of electrons from metals to non-metals, forming oppositely charged ions, which are held together by strong electrostatic force of attraction. So I'm just going over the extra information a little quicker, so you don't have to think about it. If you want to listen to this extra information, just pause the video, rewind it, slow it down. Okay, so B is wrong. C says positive ions are formed when atoms lose protons. When atoms lose protons, atoms don't lose protons, they lose electrons, they gain electrons, or they share electrons. Protons are held tightly inside the nucleus by a force called the nuclear force, which obviously is going to be taught to you guys in A levels in your physics, right? So in A2 essentially. So protons are never lost. O level में आपको बता भी देते हैं कि protons can never be lost, gained, or so on and so forth, right? Potassium iodide contains negatively charged potassium ions. No, potassium iodide is Ki, right? So potassium must have lost an electron to iodine, and iodine must have gained that electron to form the iodide ions. Oppositely charged ions are formed, which are held together by strong electrostatic force of attraction. So potassium ions are not negatively charged, they are positively charged, because it's a metal ion. Metals are positively charged. So D is wrong. Okay. Question 5 says part of the periodic table is shown. This is basically group 2 right here, and I think it's magnesium. So right, yes, we did this yesterday. So group 2, and that's number 2 is magnesium. You always label it for yourself to make it easy. And here I think this is my group 6, because after this block this is 1 2 3 4. So you start here, that's 1 2 3 4. So that's here, that's sulfur, right? So it's the second element down the group. So sulfur hai mere paas or magnesium hai mere paas. So what is he saying? The examiner is saying which type of chemical bonding is present in the oxide of F and in the oxide of G. Magnesium forms magnesium oxide, which is obviously an ionic compound because magnesium is a metal, oxygen is a non-metal. Magnesium loses 2 electrons, oxygen gains those 2 electrons, or forming oppositely charged ions held together by strong electrostatic force of attraction. So it's an ionic compound. So obviously the bonding that takes place is the ionic bonding. A and B are wrong. And if you check oxide of G, it's a non-metal, and oxygen is also a non-metal. So sulfur basically forms sulfur dioxide, sulfur trioxide. Even if you did not know this, you know that non-metals के बीच में जो bonding होती है, it's covalent bonding, it's not ionic bonding. So obviously C should be the right answer, ionic bonding, and oxide of G is covalent bonding. Yes sir. Element X and Y react to form a compound. Element X loses 2 electrons. That means it should be in group 2 because group 2 elements lose 2 electrons. Let's suppose it's magnesium. So always suppose for yourself to make things easy, right? So magnesium 2 plus, let's suppose. And element Y gains 1 electron. Gaining 1 electron means it should be in group 7 because group 7s have 7 outermost electrons. They only need 1 electron to become stable to have a complete outermost electron shell. So let's suppose it's chlorine. So when chlorine gains 1 electron, it becomes 1 minus, right? So MgCl2 बनेगा, Mg के ऊपर 2 plus, Cl के ऊपर 1 minus. You need for 2 plus you need 2 minuses, therefore 2 chloride ions चाहिए. So the formula becomes MgCl2, or what you could have done is Mg has a charge of 2 plus, Cl is 1 minus, cross multiply MgCl2, right? So that's what's forming. And Mg that you assumed, the Mg that you assumed was X, and the Y that you assumed was basically chlorine, right? So XY2. That should be the formula. So XY2 should be the formula, XY2 should be the formula. A and C are automatically wrong. Charge on X, if it loses 2 electrons, the charge should be 2 plus, not 2 minus. B is the right answer. 7 says, which statement about graphite explain why it's used as an electrode? So obviously it contains ions. No, graphite does not contain any ions. The reason why it's used as an electrode is because what are electrodes? Electrodes are solid substances which conduct electricity. And how do solid substances conduct electricity? Due to delocalized electrons, free moving electrons, or mobile electrons. Now, it has a giant covalent structure. It does have a giant covalent structure, but that does not explain why it's used as an electrode. So B is wrong. It is a metal. Graphite is not a metal. It's a giant covalent structure. It has mobile electrons. Yes, it does have mobile electrons, and that is why it can be used as an electrode. That's how it can conduct electricity. Methane CH4 burns in air to form carbon dioxide and water. What is the balanced equation for this reaction? Just write it down. Methane burns with oxygen to give you carbon dioxide and water. What we do is we first of all balance the carbons, then we balance out the hydrogens, and then in the end we balance out the oxygen. We know why we do all of this stuff, right? So you have 1 carbon on the left, 1 carbon on the right. They're automatically balanced. 4 hydrogens atoms on the left, but 2 on the right. So 2 को मैं किससे, what should I multiply 2 with to get 4? X is equal to 4 over 2. That's 2. Insert the 2 right here beautifully. So I've inserted the 2 here. It's just, don't mind my writing, please. And now let's check the oxygen. You have 2 oxygens here, and 2 times 2, 2 times 1, that's 2. So in total you have 4 oxygen atoms on the left, on the right hand side, and you only have 2 on the left. So what should I multiply 2 with? 2 को मैं किससे multiply करूँ कि 4i, right? So x is equal to 4 over 2, that's 2. So insert the beautiful 2 here. The atoms are all balanced. If you check the option, CH4 plus 2O2 gives you CO2 or 2H2O, and that is basically B, which is the right option, right? And what you could have done is you could have just, done trial and error method, check all the individual atoms of each and every check all the individual atoms of each and every element on the left and right hand side and make sure that they are equal. So A, C and D are automatically not equal. That's why it's wrong, right? Okay. It says the equation for thermal decomposition of sodium hydrogen carbonate is shown. The MR of sodium hydrogen carbonate is 84, blah, blah, blah. In an experiment, 2.1 grams of sodium hydrogen carbonate is heated, but not all of it decomposes. If not all of it decomposes, that means that we know that it's not a limiting reactant. 2.1 grams was used, but we don't know the actual amount that reacted in the experiment. So we can't perform any calculation with sodium hydrogen carbonate. You could also technically say that it's in excess. You don't know the amount, right? So it must have given us other data, and it says all of the carbon dioxide is collected at room temperature, blah blah blah. The total volume of carbon dioxide produced is 0.21 decimeter cubes. That means that you could perform calculations with 0.21 decimeter cube of carbon dioxide, because it's an absolute amount that you have gotten 0.21 decimeter cube. Here you can't use 2.1 grams, because obviously, like I said before, you don't know the amount of sodium hydrogen carbonate reacted. If you knew that, if the examiner said that 2.1 grams of sodium hydrogen carbonate is heated but only 1 gram decomposed, then you could have used either 1 gram or 0.21 decimeter cube. Both would give you the same answer, right? But here we don't know the amount of baking soda that has been used. That's why we can't do anything. So we're going to use this, right? It's saying which statement is correct. The mass of sodium carbonate, so let's calculate the mass of sodium carbonate. You have the volume of carbon dioxide. Volume is equal to mole times 24. Volume of carbon dioxide is 0.21. Moles we have to calculate. And obviously 24 is the constant. N is equal to 0.21 over 24. That gives me 0.21 over 24. It gives me 8.75 into 10 raised to the power minus 3. The reason why I calculated the moles of carbon dioxide is because obviously, when you're using stoichiometry, first of all, convert the known data into moles. Secondly, use the equation to go from the moles of the known data to the moles of the unknown data, which is sodium carbonate. And third is basically convert the moles of the unknown data, which now you have found, into the required units, right? So we got the moles of carbon dioxide. Now let's go to the moles of sodium carbonate. We know that 1 mole of carbon dioxide the ratio between carbon dioxide and sodium carbonate is 1:1. That means agar ek carbon dioxide hoga to ek sodium carbonate hoga. And if you have 8.75 into 10 raised to the power minus 3 carbon dioxides, how many sodium carbonate would there be? Obviously the same exact number. So moles of sodium carbonates are this, carbonate is the same, 8.75 into 10 raised to the power minus 3. Now calculate the mass. If I want to calculate the mass equals mole times molar mass. Mass is, we need to calculate the mass. Moles, we know it's 8.75 into 10 raised to the power minus 3. And molar mass is essentially given in the question, which is 106. So 106, you times it by this, so into 106, that gives me 0.9275. 0.9275. If you round this off, that gives you 0.93 grams. So obviously A is the right option. B is wrong. The percentage yield of carbon dioxide is 10%. You cannot calculate the percentage yield, because obviously for percentage yield you need to have theoretical amount of carbon dioxide. You must be, this is the practical amount. This is basically what is happening in the experiment, right? So 0.21 decimeter cube is formed. You don't know how much percentage this is. So let's say it's X percent. But theoretically you need to find carbon dioxide, and you can't do that because you don't know the amount of sodium hydrogen carbonate that had been decomposed, right? If you knew the amount of sodium hydrogen carbonate decomposed, then you would have found the theoretical value of carbon dioxide, the theoretical volume of carbon dioxide. And once you had that, let's suppose the theoretical value of volume would have been like 0.42. So that would have been 100%, and then obviously you would have cross multiplied. But since you don't have the amount of sodium hydrogen carbonate decomposed, you can't find the percentage yield, okay? Because theoretical value is impossible to calculate, okay? Now, an electrolysis experiment is done using carbon electrodes, essentially graphite. Hydrogen and oxygen are formed at the electrodes. What is the electrolyte? If hydrogen and oxygen are formed, let's make our chamber. You have like the first option has copper 2 plus ions, and it's aqueous copper 2 sulfate, which means you have the H plus ions and the OH minus ions as well. Between copper 2 plus and H plus, the copper 2 plus wins the race at the cathode, so hydrogen won't form. A is wrong. I don't even have to check the other ones. Now the other ions. And now B says concentrated hydrochloric acid, which means you have the H plus ions, the Cl minus ion, and the hydroxide ions because of the water. Now H plus ion will obviously go at the cathode because it's the only positive ion present. So hydrogen would form. 2H plus ions gain 2 electrons to give you the hydrogen gas, obviously. But between the chloride ion and the hydroxide ion, obviously if it's concentrated, the chloride ion would win the race and chlorine would form. So B is wrong. We need oxygen and hydrogen, right? And dilute sodium chloride, that is the right option, because obviously if you have dilute sodium chloride, that means you have the Na plus ion, the Cl minus ion, and obviously the H plus and the OH minus ion because of the aqueous state, right? So between the Na plus and the H plus ion, the H plus ions win the race, and between the chloride ion and the hydroxide ion, because it's dilute, therefore the hydroxide wins the race. 4 hydroxide ions go together to give you 2 H2O molecules, 1 O2 molecule, and they each lose 1 electron, so in total 4 electrons are lost. So oxygen is formed, and obviously hydrogen is formed. So C is the right option. D is wrong because molten potassium oxide only has the K plus ion and the O2 minus ion, so hydrogen won't be formed. Potassium would be formed at the cathode. Potassium would gain an electron, become potassium, and oxygen would form at the anode. So oxygen would form at the anode, but not there would not be hydrogen. You need hydrogen and oxygen both, right? So here 2 oxygen ions would go together, each would lose 2 electrons, so in total 4 electrons would be lost and O2 would be formed. But who cares about this? D is wrong. 11 says concentrated aqueous copper sulfate is electrolyzed using copper electrodes. What is the half equation at the cathode? Obviously make our terminal again. That's the negative terminal is my cathode, the positive is the anode. If you don't remember it, it's panic. Positive is anode and negative is cathode only in electrolysis, right? So you have the copper 2 plus ions, the H plus ions, the SO4 2 minus ion, and obviously you have the hydroxide ion, this is the positive and this is the negative terminal, but it's made up of copper, right? That's the thing to note. If it's made up of copper, it's essentially the same thing jo purification of copper karte the, electroplating karte the. Kya hoga? The copper 2 plus ion would win the race and go at the cathode, gain 2 electrons and become copper, and obviously the anode would, because it's made up of copper, it's not inert, it's going to take part in the reaction. The anode would start to dissolve to compensate for these copper 2 plus ions. So the anode dissolves, copper dissolves to give you the copper 2 plus ions and 2 electrons. So that's what's going to happen at the anode. If you don't get this, your concepts are very weak. Go on and watch the videos available to public, because that's all I can do, right? I can't go into explaining each and every concept in quite a lot. So what will be the observation? I've done that yesterday, right? So I'm not doing that. I'm just solving the paper. Okay. So copper 2 plus, what is happening at the cathode? Copper 2 plus ions are gaining 2 electrons, becoming copper. D is the right option. When powdered sodium carbonate and aqueous ethanoic acid are mixed, the temperature of the mixture falls. I said this before, I said it a gazillion times, I'll say it again for those of you who have weaker concepts in this case. Remember, you guys always get confused whether, because you guys think that obviously in endothermic reactions the system energy will increase, the temperature of the system increases but the surrounding decreases, and in exothermic the heat is released, so the temperature of the surroundings increases and the temperature of the system decreases. But you need to understand, you guys can only observe the surroundings. So whenever we observe a mixture, whenever we observe a beaker getting warmer or cooler, or that is all related to the surroundings. Unless the question says the system, what happens to the system, we can, because as humans, what happens to the system cannot be observed by us. We can only observe the surroundings because it's on a very, very micro level, right? So you can't observe that, and you can only observe the energy change. So if the temperature of the mixture falls, the temperature of the surrounding falls. Just substitute it with the surroundings, right? So the temperature of the surrounding falls. And when does the temperature of the surrounding fall? When it's an endothermic reaction, energy is taken in from the surroundings, the temperature of the surrounding falls and the temperature of the system rises, right? Or the internal chemical potential energy of the system rises. So the reaction is endothermic, yes, and delta H is negative, no. For endothermic, the delta H should be positive, therefore B is the right answer. It's not exo, D and C and wrong. Okay. Magnesium powder react with excess dilute hydrochloric acid to produce hydrogen gas. Okay. Which statement about this reaction? The smaller the particles of magnesium powder, the more slowly the hydrogen is produced? No. The smaller the particles, that means the greater the surface area, and the greater the surface area, therefore the greater the rate of reaction, and that means that the faster the hydrogen gas is produced. So one is wrong. The higher the temperature, the faster the magnesium powder disappears. Yes, because the higher the temperature means the higher the rate of reactions, frequency of collisions increases, particles possess more energy, so on and so forth, blah, blah, blah. And therefore, the rate of reaction is faster. That's why the faster the magnesium powder reacts and disappears. So 2 is right. 3 says the lower the concentration of dilute hydrochloric acid, the faster the rate of reaction. No, the lower the concentration, the slower the rate of reaction, because there are now less particles per unit volume and so on and so forth. Frequency of collision decreases and so on. Yeah. And 4 says the faster the magnesium powder disappears, the faster the rate of reaction. Yes, the same thing. The faster the magnesium powder disappears, that means the rate is very fast. The collisions are quicker. The magnesium powder is being used up very quickly, right? So that is true. 2 and 4 are right, so obviously C is the right option. The graph shows the reaction between two aqueous compounds X and Y is slow and exothermic. The graph shows how the rate of reaction changes with time. A student suggests that the rate of reaction decreases with time because obviously the rate of the reaction would decrease because initially you have the maximum concentration of these reactants, or you could say the maximum amount of these reactions, so the frequency of collisions is really high. But as these reactants get used up, the frequency of collisions start to decrease, and essentially look at the rate is also decreasing with time. So the activation energy decreases. No, you're not using any catalyst whatsoever. There is no link to the activation energy here. The speed of the molecules decreases. Speed can only be affected by temperature. Remember, the speed of the reaction can only be affected by temperature because only temperature affects the kinetic energy. And if there is an increase in temperature, obviously the kinetic energy would increase, and kinetic energy is half mv squared. Therefore, the speed increases. It's basic physics for you guys, right? And if the temperature decreases, obviously kinetic energy decreases, which means that the speed of the particles decreases. So the speed can only be affected by temperature, neither by concentration, nor by surface area, nor by anything else, right? So that's basically that. Now, 2 is also wrong. The concentration of both X and Y decrease with time. Yes, concentration in rates basically means the amount. So amount of X and Y decreases, therefore frequency of collisions decreases, and so on and so forth. So D is the right option. Okay. Hydrogen reacts with iodine to form hydrogen iodide. Which statements explain why the reaction is faster when the pressure is increased? If the pressure is increased, the particles, the gas particles, because they're all gases, it only affects the gas particles, right? So if they are gases, you increase the pressure, the gas particles, they come closer together, therefore the frequency of collisions increases. That's why the rate increases here, right? So it's saying at higher pressure, the molecules are moving faster. That means the speed of the molecules is greater. But that's wrong. I told you the speed of the molecules only can be affected by temperature, not by pressure. So at higher pressure, 1 is wrong, right? At higher particles, more molecules have the required activation energy. No, it's at higher temperature that more molecules have the required activation energy because they now have a greater kinetic energy. So 2 is wrong because obviously energy can only be, energy can neither be created nor destroyed, only converted from one form to another, and temperature is a form of energy in O levels in IGCSE essentially. So the temperature ki jo energy है, it's just being converted into kinetic energy, but pressure to energy nahi hai. Pressure is not energy, right? So if these were temperatures, then it would have been right, but these are pressure, right? So at higher pressure, the molecules come closer together, yes, and that results in a higher frequency of collisions and more frequent collisions, and the rate increase. And part 4 says at higher pressure the molecules collide more frequently, yes, because they come closer together. So 3 and 4 are the right option. D is right. Okay. Ammonium sulfate is used as fertilizer. It is made from ammonia and sulfuric acid. The blah 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 blah. Okay. Fill in the words. So the ammonia is made by the contact. No, ammonia is made by Haber process. A is wrong. B is saying ammonia is made by Haber process, but the catalyst used is vanadium oxide. No, catalyst uses iron. B is also wrong. A and B both are wrong. Okay. C says sulfuric acid is made from contact process and vanadium oxide is used. Yes, that is sulfuric acid formation, right? That is one of the steps for the formation of sulfuric acid. Sulfuric acid is made by Haber process. No, it's made by contact process. It's called contact process, right? The reversible reaction is shown when the reaction has reached equilibrium, more T is added. Now, if you add more T, what would happen is, I told you, Le Chatelet said if a change to any system, let me just explain Le Chatelet very, very simply. A levels में आप ज़्यादा अच्छा पढ़ते हैं, मैंने O levels में आपको एक simple बात बताई थी, that if you make any change when the system is at equilibrium and you try to make a change to that equilibrium, you change a certain condition that will affect that equilibrium, the system will actually oppose your change. System aapse ladega, it will rebel, it will oppose your change, right? So if you add more T, the system will want to decrease the amount of T, right? And how will it do that? It will shift the equilibriums it will shift the equilibrium backwards. And how will it do that? By making more P, Q and R and reducing the amount of S and T, right? S and T will get used up, it will break down to make P, Q and R. That is what happens, because if you try to shift, if you try to mess with the equilibrium will mess with you. So if I added more T, the equilibrium will want to decrease the amount of T. And how will it do that? By shifting the equilibrium to the left so that T and S are utilized and used and more P, Q and R are formed. So let's check this out. It says, after the addition of T, which other substances increase in concentration? Obviously, T and S will decrease in concentration, PQR would increase. So PQR only, yeah. in which equation is the underlying substance acting as a reducing agent. Reducing anything that is oxidized is a reducing agent. And if you look into the technical definition of I'm not going to go into detail obviously, because I can explain the entire concept here, which I won't. I'll just solve the question, but I'll just explain it to a certain extent which is required in this question. So if you take the definition for reducing agents are substances that oxidizes itself to reduce another substance. That's why it's an agent, right? What does a marketing agent do for you guys? A marketing agent markets for you, right? What does an advertising agent do? He advertises for you. What does a selling agent do for you? A selling agent sells stuff for you. So reducing agent would reduce you, right? So that is it. So reducing agent reduces the other substance. That's why it's known as an agent. It reduces the other substance and gets oxidized itself, right? So if you check carbon monoxide is basically, what is it doing to iron oxide? You don't even have to calculate the oxidation states and so on. So just check what it's doing to iron oxide. Iron had 3 oxygens, now it doesn't have any oxygen, and loss of oxygens is reduction. And yes, it is a reducing agent because iron oxide has been reduced. And who has reduced it? Carbon monoxide. So carbon monoxide got oxidized itself to carbon dioxide. It gained an oxygen, but it obviously reduced. You could just look at one aspect. If iron oxide has been reduced, how did it get reduced? By carbon monoxide, right? Because it stole its oxygens. And carbon dioxide, check this out. What is carbon dioxide doing to carbon, right? What is it doing to carbon? It is actually oxidizing it. It's giving it one more oxygen. And if you get confused, just calculate the oxidation state, right? So here it's the oxidizing agent because coke is actually gaining an oxygen. It's getting oxidized, right? So here's an copper oxide ko agar dekhiye, what's it doing to hydrogen? What is it doing to hydrogen? It's oxidizing hydrogen. Therefore it should be an oxidizing agent. It's giving the hydrogen one oxygen. Gain of oxygen is oxidation, right? You could obviously calculate oxidation. If you take D out, D is not even an oxidation reaction. It's called the combination reaction. I feel like, yeah, it's a combination reaction where atoms, where compounds and substances, they combine to form just one other product, right? One other substance. And that is what. But if you check the oxidation state, calcium is +2, oxygen is -2, hydrogen is +1, oxygen is group 6 -2, calcium is again +2, oxygen group 6 -2, hydrogen is +1. The oxidation states are the same. There's nothing happening, right? 19. An aqueous solution reacts with a solid. The products are an alkaline gas. If it's an alkaline gas, obviously that means that it should be basic in nature. And saying it's an alkaline gas, a salt, and water, right? Okay. An aqueous solution reacts with a solid. So what should the solution be and what should the solid be? Obviously, if you check magnesium carbonate out, magnesium carbonate, first of all, does not react with sodium carbonate. A is wrong because that's also a base and that's also a base, right? Magnesium carbonates are weak bases. But if I know we know that all metal carbonates react with acid, but it gives you a metal chloride. It will give you magnesium chloride, H2O, and carbon dioxide, right? These are the products. It gives you salt, water, and carbon dioxide. But carbon dioxide is not an alkaline gas. It's an acidic gas, non-metal oxide, right? Non-metal oxide are acidic oxides. So B is wrong. Hydrochloric acid plus ammonium chloride. Ammonium chloride is slightly acidic. Hydrochloric acid is an acid, so C will not undergo reaction. D is the only option left, and this is the reaction that I've taught you guys, which I tell you that most teachers tend to skip. Ammonium chloride, they're basically ammonium salts are slightly acidic, so they react with strong bases like sodium hydroxide. They form salt, ammonia, and water. So sodium chloride will be formed, and obviously the hydrogen here and the OH here would form water, and the NH3 would be left, which would be your ammonia, right? So what would be formed? Sodium chloride plus H2O plus NH3, and NH3 we know is an alkaline gas or a basic gas, right? So yes, D is the right option. Now 20 says butanoic acid partially dissociates in aqueous solution. What should be which row about butanoic? If it's an acid, partially dissociate means it's a weak acid, right? So it would have a pH lower than 7, but not much lower than 7, right? It can't be 0, 1, or 2, right? That's strong acids. But let's see the options given to us. So it's saying what should be the pH? The pH cannot be 8, the pH cannot be 10, obviously, because 8 and 10 are basic pHs, not acidic pHs. 7 se upar basic hota hai, 7 se niche acidic. So C and D are wrong. Between A and B, we have to select. Now it's saying effect on thymolphthalene. Thymolphthalene, it's colorless in an acid. Thymolphthalene is colorless in acid, and obviously blue in a base, right, or in alkali. So colorless in an acid hona chahiye, so turns colorless. Therefore B should be the right option. Okay. Copper 2 sulfate is prepared by adding excess copper carbonate to sulfuric acid. It's basically the preparation of a soluble salt other than group 1. Why do we use excess copper carbonate? Because if this is excess, it will basically use up all the sulfuric acid. Obviously, copper carbonate plus H2SO4 would give you copper sulfate plus water and plus carbon dioxide, right? Because it's a metal carbonate. That's what's going to CO3 and CO2, right? That's what's going to happen. So if you use excess copper carbonate, all the acid would be used up, and then you would have been left with some copper carbonate here, and copper sulfate would have been formed, which would be the aqueous solution. Then you basically filter it. The copper carbonate, the excess copper carbonate that remains after the experiment will be collected as residue during filtration, and copper sulfate would be collected as filtrate, which would be poured into an evaporating dish, heated till the point of crystallization, and beautiful blue salts would be formed, right? Blue crystals would be formed, yeah. And the reason why you don't use, and that's why it's called a limiting, it's called the excess method, not the limiting, it's called the excess method, because you use the metal carbonate in excess. And why don't you use the acid in excess? One student asked me once, it's not a part of your course, but if you use the acid in excess, then what will happen is, instead of having a situation like this, what would be left here is you would have like aqueous copper sulfate, and you would also have like aqueous H2SO4 left at the end. Now to separate these two is a bit challenging. It's quite it's very, very hard to do it, and it's nearly impossible. It will lead to impurities, because removing this excess metal carbonate is easy. You just do filtration, but removing this is quite difficult, right? So why is excess copper carbonate used? So that all this sulfuric acid is used, so all this sulfuric acid is reacted. So to ensure all the copper carbonate is reacted, if it's in excess, how can all the copper carbonate react? Come on, A is wrong. To ensure all the sulfuric acid is reacted, yes. To increase the rate of reaction does not depend on these things. It depends on concentration, temperature, surface area, and blah blah blah, right? To increase the amount of copper sulfate produced, no. If it's in excess does not dictate the amount of product produced. The limiting reactant does. So D is wrong. Part of the periodic table is shown which element has 2 electrons. If it has 2 electrons, it should be in group 2 in its outermost shell, right? So it should be in group 2, and has 3 electron shell means it should be in period 3. Group 2 and period 3, because the number of shells tells you the row number, which is essentially called, with the horizontal rows are called periods and the vertical columns are called groups. So group 2 mein hona chahiye, this is group 1, that's group 2. It should be either B or C. Period 3, this is period 1, that's period 2, that's period 3. C is the right option. Remember, don't start your periods with this. Oh, this is period 1, that's period 2. No, the period starts, the horizontal rows basically start right here from hydrogen and helium. That's the first row, right? So this is the first period, okay? And I think C is magnesium. Magnesium is 1224, first shell 2, second shell 8, and the third shell can hold up to a maximum of 8, but only 2 are left. So yes, it has 1, 2, 3 shells, and the outermost electron has 2, right? You could check the periodic table for that. Elements in group 1 and group 2 show the same trends in their reaction with water and their blah blah blah. Which row shows the properties of barium compared to calcium? Calcium in group 2 is above barium in the group, right? And we know down the group 1 and group 2s, the reactivity increases, right? So reactivity increases, that means that barium will react faster with water. So C and D are wrong. And why does the reactivity increase? I've explained this in quite a lot of detail. You studied this in AS2, but I've explained this, so I'm not going to go into it. It's very simple concept, right? It depends on the gain and loss of electrons and blah blah blah, but why I've taught you guys this, right? And the size of the atoms. Now what happens to the density? The density also increases down the group for group 2s, and the reason for that is very simple, because the mass to volume density क्या है? Rho, जो physics के teacher आपको बताएंगे, rho is equal to mass over volume, right? Density is equal to mass over volume. So the reason why the density increases down the group is the mass to volume ratio is increases. So that means if the mass is increasing by 10, the volume is increasing by 5, right? Let's suppose like that. So that's why the numerator keeps on increasing more than the denominator. So density is higher. A is the right option, yeah. 24 says which pair of compounds shows a transition element in 2 different oxidation states. So for this, what you could do is then underline this, call this X. You have 2 of those, and then oxygen has an oxidation state of -2. You have 3 of those, times it by 3. Overall oxidation state is 0. 2x minus 6 equals 0. X equal to 6 over 2, that is 3. You could either do all of this stuff, or what you could do is simply use a rule. You you know that the charge on the ion is the oxidation state of an ion is the same as its charge. Separate them into charges. Cr2O3, how is this formed? Cr must have a charge of 3 plus, O must have a charge of 2 minus. That's why when you cross multiply, Cr2O3 is formed. So the charge on the ion, this is the rule, the charge on the ion is the same as its oxidation state, or the other way around, right? So the oxidation state is the same as the charge on an ion, right? So the charge on chromium is 3 plus, therefore the oxidation state is plus 3. Oxygen ka charge 2 minus hai, oxidation state is minus. So similarly do this here. Chromium sulfate is formed, right? So chromium has a charge of 3 plus. You just take these subscripts back where they were, right? Back into their superscripts. So chromium had 3 plus charge, and bring this 2 back here. So sulfate was 2 minus. That's why when you cross multiply, Cr2SO4 whole thrice was formed. So chromium is 3 plus and sulfate is. So that's how you save time, right? So A is wrong because A does not have different oxidation states. Both are plus 3. Now here B is the right option, because copper Cu2O means that copper had 1 plus, O was 2 minus. That's how when you cross multiply, CO to Cu2O was formed, right? Copper 2O. And copper carbonate, if you check this out, copper has a charge of 2 plus and CO3 is 2 minus. That's why copper carbonate is CuCO3. I tell you, as some of the students say, sir, when we cross multiply, we should end up with Cu2CO3, CO3 whole twice. I tell you guys, that's why don't cross multiply. That's the wrong concept. It's a trick, right? If you are still gonna cross multiply, then simplify it, because they both are in two ka table, so 2 cut jayenge aapas mein. But that's not the real concept. The real concept is that the charges must be balanced, right? So for 1 2 plus, you need 1 2 minus. This cross multiplication is just a trick, but the real concept, like iron oxide, Fe2 plus and O2 minus. Do we write Fe2O2 or do we write FeO? We write FeO because we know the charges are balanced. For 1 2 plus, you need 1 2 minus. That's the real concept behind it, right? But if you were to still use cross multiplication, then you simplify 2 or 2 cut jayega FeO. Yeah? Okay, zinc sulfide and zinc sulfate. Again, zinc is going to be 2 plus and S is 2 minus, because sulfur is in group 6, 2 minus. And again, zinc is 2 plus and SO4 is 2 minus. How do I know this? Because sulfate is 2 minus, so automatically if there is no subscript here, zinc should also be 2 plus, right? That's how zinc sulfate is. So C is wrong and D is also wrong. B is the right option. Okay. Which description of brass is correct? Brass is an alloy, which means it's a mixture. Alloys are a mixture of metal with other elements. It's not a compound. It's not a compound. A and B are wrong. Is it copper plus zinc or copper plus tin? I told you guys an easy way to remember. I don't know. Teachers just give you guys the rote learning. They don't teach you how to memorize stuff, right? Some things need memorization. The way I taught my students was, okay, both have copper, brass and bronze, but one has tin and one has zinc. Now the one that has more letters in it, that would have the smaller letter one. So tin has more letters or zinc? Zinc has more letters, right? And tin has less letters. So the one that has more letters, to compensate for more letters here, you will have the smaller letter thing. And the one that has the lesser letters here, you would have the more letters things, which is the zinc, right? So that's how you could, create tricks for yourself. So brass is copper plus zinc. That's why. And that's why that's how I have remembered it throughout my life. मतलब मैं ऐसे ही remember करता हूँ. It's not like I just know it and I know it by tricks and tips, right? So copper plus zinc right here should be brass. Okay, brass ही पूछा यहाँ. What is the symbol of the metal in the manufacture of aircraft? Because of its low density, it's aluminum. Aluminum has low density, and that gives it better aerodynamics and so on and so forth. Okay. Which substances react to form hydrogen gas? Calcium plus water, calcium plus H2O. Obviously, the metal would displace the hydrogen. Calcium hydroxide would form, and water and hydrogen gas would be formed, right? We know metal plus H2O would give me metal hydroxide and hydrogen gas. Silver plus dilute hydrochloric acid. Silver will be added to HCl, and obviously silver chloride would be formed and hydrochloride. You dumbos, no sirree, because silver is lower in the reactivity series than hydro. I know most of you would have done this, but silver is lower. You need to be very careful. Silver, copper, gold, they don't react with acids because they are lower in the reactivity series. Therefore, it cannot displace the hydrogen of the acid. So 2 is wrong. 1 is right, 2 is wrong. Magnesium plus steam. Now, obviously, magnesium plus steam, what it does is H2O gas, it will give you magnesium oxide and hydrogen. because you're using steam, the reaction is so, think about it like this, those of you who don't remember this, because the reaction is so fast, the rate of reaction is so high, and it goes on so spontaneously because of steam is very hot, it has a higher temperature, so magnesium ends up displacing both the hydrogen atoms to give you H2, and magnesium oxide is formed. But magnesium plus H2O liquid, which is just water, not steam, the magnesium is not so strong as to remove both the hydrogens, it simply just removes one hydrogen, and magnesium hydroxide is formed and hydrogen gas is formed. That's how you could remember it. But hydrogen gas is formed in either scenario. So 3 is also right, and obviously 4 should be right. Zinc plus dilutes hydrochloric acid. Zinc will, obviously displace the hydrogen of the acid. Zinc chloride would be formed and H2 gas would be formed. So 4 is also right. 1, 3, 4 is the right option. Coke and lime salts are two raw materials, blah blah blah. Okay, it's saying what are the processes. I'm not going to see. Now, if I were discussing this in detail, I would go on into explaining the entire process of, extraction of iron from hematite and what it is and all the related concepts. But obviously, I'm just solving the paper, so let's just solve the paper. So Coke, the reaction that Coke undergoes, Coke reacts with oxygen to give you carbon dioxide. It's a redox reaction. Obviously, you just need to see, obviously, that carbon gained oxygen. So if there was a gain of oxygen, oxidation took place, and if there is oxidation, automatically reduction would take place. If you don't trust me, do the oxidation statement. Carbon here is 0 because it's in its pure elemental state. Oxygen is 0 because it's in its pure elemental state. It has no charge. Carbon here is plus 4. You could calculate it. I know it's plus 4, right? You could call it X and then calculate it. And oxygen is minus 2 because it's in group 6. So what happened? There was an increase in oxidation state of carbon from 0 to plus 4. Therefore, there's oxidation, and there was a decrease in oxidation state of oxygen from 0 to minus 2. Therefore, it is reduction, right? So it is a redox reaction. C and D are wrong. And limestone undergoes thermal decomposition. B is the right option. How? Because calcium carbonate undergoes thermal decomposition, which means because of the action of heat, it basically, the substance breaks down. So calcium monoxide is formed and carbon dioxide is formed, right? And if you don't trust me, calculate the oxidation state of all of them. They're going to be the same on left and right hand side. Okay. Some combustion reactions produce pollutant gases. Which reactions produce a pollutant gas that is not present in clean air? Clean air means that you have like 78% nitrogen, 21% oxygen, and 1% of carbon dioxide and other gases, other noble gases like argon and krypton and helium and so on, right? Mostly argon. Okay, so what is not present in clean gas? Let's check this out. Is carbon monoxide present in clean gas, clean air? Did I mention carbon monoxide anywhere here? No, carbon monoxide is a pollutant, right? It's a poisonous gas that is produced because of incomplete combustion and so on and so forth. So it irritates the lungs and causes skin damage and so on and so forth. So it's not present in clean air, it's present in polluted air. Water, H2O. Now, I've not mentioned H2O here, but it's common sense from your day-to-day lives that water vapors are all around you. Humidity, right? Humidity is what? It's essentially water vapor. So they are around you. Water are present in the form of a gas, which we call water vapor. So these are present in clean air, right? Carbon dioxide present in clean air. I just said that 1% of carbon dioxide. It must be there, right? Because we respire. When we respire, we give out carbon dioxide, right? Respiration jab hum karte hain, glucose basically breaks down. Okay, and nitrogen plus oxygen gives you nitrogen monoxide. This is also because of the high temperature of the internal combustion engines. It's also a pollutant, or maybe like because of lightning it happened, because lightning provided it with that activation energy. So this is a pollutant. It shouldn't be present in the clean air. So obviously 2 and 3 should be present, and it's asking us what should not be present. So 1 and 4 should not be present. B is the right answer. 1 mole of alkane Y produces 72 decimeter cube of carbon dioxide when burned in excess oxygen measured. So it's saying what is Y. Now obviously if I were explaining it, I would do all of this, but if I'm solving it, I automatically know which one it is, because if it is giving you 72 decimeter cube of carbon dioxide, that means how many moles is it giving you? V is equal to N into 24. So you calculate the number of moles, which is 72 over 24, that gives you 3. Check this out, which reaction is giving you 3 moles of carbon dioxide, right? Now, there is one way to go about it, that is trial and error method. Write all the equations for it, balance it, and you will find out the answer. Or the other method is that I've taught you guys. You should know the general equation. CXHY plus O2 gives you XCO2 plus Y over 2 H2O. That means that the number of carbons in the hydrocarbons would give you, check this out, don't trust me, write down all the balancing equations. The number of carbons here should be the number of the number of moles of carbon dioxide that are forming, and the number of hydrogens that are here in this hydrocarbon, half of those hydrogens will be forming here, right? If you don't trust me, check this out. But if I know this, that means that if 3 moles of carbon dioxide are formed, that means this C should be 3, and which C is 3? Propane. Prop means 3 carbons. D is the right answer. If you don't trust me, check this out. C3H8 plus O2 gives you 3CO2 plus, this is 8, so this should be 4H2O. And it's the hydrogens and carbons are balanced, and then in the end you balance out the oxygens. I don't even care about the balancing of oxygen because it's irrelevant here. The structure of an organic compound is shown. What is it? Obviously the carbonyl carbon, the carbon bond double bonded to the oxygen, and the adjacent carbons, they are coming from the acid, and the carbon bonded to the oxygen, that's going to come from the alcohol. So meth, this came from the ethanoic acid, so this should be ethanoate because the IC finishes and the OA, the ATE comes in it, and this should be meth. It's only one carbon, so it should be, it came from methanol, so it should be methyl. So the entire compound should be called methyl ethanoate. So methyl ethanoate, C is the right option, right? What is the structural formula of a compound from when bromine reacts with bromine? Draw the structure, right? So meth, eth, prop, and because it's an E, that means there must be a double bond, and obviously complete the bonds. Bromine के साथ reaction कर रहा है, the double bond will break. Obviously the double bond breaks. Why does it break? Study in A levels. This bromine will be bonded here, this bromine will be bonded here. So these are my hydrogens, these are my carbons, and this is the bromine right here, and that's the bromine right here, right? दोनों के side पे आ जाएगा. Now just write the structural formula. How? We just take individual carbons. So this carbon is bonded to 3 hydrogens, we say CH3. Then this carbon is bonded to 1 hydrogen and 1 bromine, I'm saying CH and Br. And then this carbon is bonded to 2 hydrogens and 1 bromine, so C bonded to 2 hydrogen and 1 bromine. So CH3 CHBr CH2Br, and that is CH3 CHBr CH2Br. A is the right option. Ethanol is produced industrially by fermentation and is also catalyzed by blah blah blah. Advantage of each process. Okay. Fermentation, the reactant used is renewable. Yes, that is the advantage, because glucose is a renewable source of energy, and glucose is added, yeast is added to glucose at a temperature of anywhere between 25 to 37 degrees Celsius, provided you could write any of the temperature, and it gives you ethanol and carbon dioxide, right? So it is a renewable reactant. It is a very rapid reaction. No, fermentation is a batch process. It's a slow reaction. Batch process actually means कि उसको आप batches में करते हैं. You can't do it continuously, right? Like alkenes की hydration, जब alkenes की जब hydration होती है, that's a continuous process in the industry. It's going on and on and on. But for fermentation, you need batches, right? So that's one batch of my alcohol beautiful bottles, and the other batch and the other batch. So you have to, separate them into batches. That makes it a slow process, and it's a batch process. So it's not rapid, it's slow. C and D are wrong. Okay. Catalyzed addition reaction involving steel, it's a continuous process. Yes, it is a continuous process. It requires little energy. Tell me, is 300 degrees Celsius little energy? Because we know that alkene plus H2O, which is in the gas state, H2O is steam essentially. So alkene plus steam, you have to provide 300 degrees Celsius of temperature. You have to provide 70 atmospheric pressure. You have to provide acidified phosphoric acid. But 300 degrees Celsius, is that little energy? No, it's a very high energy, right? It requires a lot of energy. It's very costly, right? So B is also wrong. It is a continuous process. A is the right option. Okay. Carboxylic acid reacts with alcohol when warmed with an acid catalyst. Obviously, what is that acid? Carboxylic acid plus alcohol, and the catalyst is concentrated sulfuric acid, concentrated H2SO4, and you heat it a little bit, obviously, and esters are formed, right? That's the formation of it. So an ester is formed, neither alkene, blah blah blah. Okay. Nylon is formed by what? Which structure represents nylon? Nylon ki monomers kya hai? You have dicarboxylic acids and diamine, right? So diamine and dicarboxylic acid. So you could also draw it for yourself. You should have many tricks and tips up your sleeves now, which I've taught you throughout, and it's common sense, but that comes after a lot of practice, right? I'm still taking a lot of time solving this because obviously I'm explaining. So water molecule is removed because it's a condensation process. These are hydrogens, right? That's the diamine group. And obviously the hydroxide, the OH is removed here and the H is removed here. So OH goes, OH and H goes to give you water, and this OH and H goes to give you water, and you join these two together. My bad, join them together right here. This is joined, and these are my continuity bonds. So on one side of the box there should be two C double bonded to the O's, and on the other side of the box there should be two NH. Now if you check this out, on one side of the box you have the carbonyl carbon, and the other side of the box you have the NH. So this is wrong, because this is essentially representing protein, right? One is the acid, one is coming from the acid, one is coming from the amine. So this is essentially representing amino acids. B is also wrong because the representation is not right. C and D mein option hai. If you check this out, I don't know what they've done here. What is this? What are those? Is this coming in our bonding? No, this is just like a simple amide linkage, which is right here. This is my amide linkage, right? Where is this oxygen coming from? Apne se question mark. C is the right option. There is no oxygen being involved. Which structure represents the repeat unit for the addition polymer but1-ene? Draw cuts after every 2 carbon. Boom, 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 boom. And that will give you the monomer or the repeat unit. This is what? You draw cuts and you draw a double bond in between, right? So this is meth. As ye cuts nahi honge na, then this becomes the monomer. This is the actual repeat unit, right? So it's meth at ethene. The ethene is, we need but1-ene, not ethene. Now here again you will get ethene. C is wrong. Here when you erase these and this double bond forms again, this will give you meth at pro-but. This is butene, but the double bond is between 2 and 3, and the smaller number is taken. So this is butene, but but2-ene hai, not but1-ene. If you check this out, remove these, think that they are not present, and the double bond is here to complete the 4 bonds. Now if you check this out, this is 1, 2 and 3, 4, right? So 3 or 4. This is meth eth pro-but. It's but, but the double bond is between 1 and 2, and we take the smaller number, so it's but1-ene. Therefore A is the right option. 2 grams of powdered calcium carbonate is added to 50 centimeter cube of hydrochloric acid. Which apparatus is used to measure the quantities of this and this? Calcium carbonate, because it's mass, for mass we use balances, not pipettes. Pipettes are used to measure volumes, for fixed volumes, right? Hydrochloric acid, between A and B, if you check this out, we don't use thermometers to measure the hydrochloric 50 centimeter cube of hydrochloric. A thermometer is used to measure temperature. I swear to God, the student who got this MCQ wrong, I think he should jump off a cliff. No, you shouldn't, but my God. So A is the right option. You might be wondering, sir, why not pipette, right? So they won't give you ambiguities here, right? So if there was a pipette as well, then they must have, then that is an ambiguity. Agar ye thermometer ke beech mein pipette hota, then obviously I would still go for the burette because it's more precise, but they wouldn't put you in such ambiguity type situations. I don't know what the English for this is, but yeah. The diagram shows a chromatogram obtained from the colors. You call it a chromatogram after it's dried, right? How many different red dyes are present in sweets? So there are multiple sweets. There's checking the red dyes. So you guys would go for it's 1, it's 2, it's 3, it's 4, and yeah, D is the right option. But no, you dumbos, it's saying that different red dyes. These two are the same. These two are the same. So in total, in reality, you only have 2 different red dyes. One is this and one is this. These two are the same and these two are the same. So B is the right option, not D. A mixture contains sand and an aqueous solution of sodium chloride. So what's happening is, let's suppose that's my flask, Erlenmeyer flask or conical flask. You have sand particles here and you have like aqueous solution of sodium chloride. So how do you separate them? First of all, we'll perform filtration. The sand particles will be obtained as residue. Aqueous sodium chloride will be right here, and then you pour this in an evaporating dish, and then you heat it till the point of crystallization, and obviously solid sodium chloride starts to form, right? So that is what's going to happen. So first of all, we perform filtration followed by crystallization, right? Because this is crystallization. Filtration to get the sand, crystallization to get sodium chloride. C is the right option. And even if you just knew filtration, A, B, and D were automatically wrong. 40 says a student tests an unknown compound M. The compound produces lilac flame using a test color. Now you should know this, man. Come on, like, god damn. Okay, so K plus is giving, potassium ion gives us the lilac color, and produces a gas which turns the lime water milky. It's basically carbon dioxide. And how is carbon dioxide gas produced? What thing do you need to test to produce carbon dioxide? It's basically the carbonate ion. So carbonate ion, when you, like, let's suppose I have magnesium carbonate, when I react it with dilute hydrochloric acid, therefore it will give us carbon dioxide which will turn lime water milky, right? So that we have to test for carbonate ion, and that is what happens. So carbonate ion was the negative ion and potassium ion was the positive ion. So obviously the M is basically, substance M is with us potassium carbonate, K plus and CO3 2 minus, right? Cross multiply, you get K2 CO3. So those of you who are, thinking of skipping the tests and stuff, don't do that. You're gonna suffer in certain MCQs. And that's it, guys. That's literally it. So I went a little quicker over the MCQs. I could have done this still in half the time because I'm me, obviously. But when you, and I still explained every single MCQ in quite a lot of detail, not related concepts and stuff like that, but obviously each MCQ was discussed in quite a lot of detail. But you guys, when you guys are practicing, you should have the same mindset. There are quite a few days left. You should practice in such a way that revise your concepts rather than you guys just rote learning the MCQs. And yeah, those of you who think that your concepts are pretty bad and so on and so forth, then that's the last resort, right? Because the MCQs are quite literally repeated. The only things that they change are few things here and there. They just change Ajmal from Ali and Balloon from Box and so on and so forth. So even if you just solve the MCQs and just check over the marking scheme and start remembering or rote learning it, that'll still do the job for you. But that is very risky. It's I will never suggest that. It's just ruining your concepts and rote learning your way through O levels in IGC. So that's very stupid. So practice like this, all will be well. You could join the discussion forum if you want. It's available. It's free to everybody on WhatsApp, so everybody can send in their questions there. I'm not that regular there, but the students are brilliant. They're quite literally very amazing. They'll help you there, right? But I'm also there available if I feel like certain questions can't be answered, and they continuously tag me, you guys, so then I answer the questions. But that's pretty much it, guys. Keep spreading love. God bless. Godspeed. Bye.